It says a child pulls a wagon with a force of 65 pounds. And so here's like the wagon. Here's our child. Whoop. And so the force that it's talking about of 65 pounds is this right here. And of course the force is along the handle, and the handle makes a 45-degree angle with the ground. So this angle with the ground is like, this is the horizontal surface. So this angle right here is 45 degrees. And the question is, how much work is done while pulling the wagon 40 feet? So work is just force times distance. Right, that's just a formula from physics. So you might be tempted to be like, well, the force is 65 pounds and the distance is 40 feet. So 65 times 40 is like 2,600 or something like that. But the trick here is that the force isn't in the exact direction of the distance, right? So this is my distance. And the force is not totally in the direction of the distance. It's like a little bit off. It's like 45 degrees away from it. And so what we're going to have to do in this case, for this type of physics problem, is you say, I don't just need the total force, which is somewhat upward and somewhat horizontal. I just need the component of the force that is perfectly horizontal in the direction that we're pulling the wagon. So we need the projection. Yeah, exactly. So that's what we're going to do. We're going to say, I want the projection of this vector in the direction of the distance. And without using the projection formula, let's just think about what the projection would mean here. Remember, this is my force vector, and it makes a 45-degree angle with my distance vector. This projection is going to be a vector that looks like this, right? It's just the component of the force that's in the same direction as the distance. And so that was what we're asking for. And just in terms of trigonometry, this would be perfect. F cosine theta, because cosine theta is the ratio of the adjacent side to the hypotenuse, and we want the adjacent side of this right triangle here. And so, of course, F was 65. What is cosine of 45 degrees? Root 2 over 2. And don't forget to multiply this projection of F onto D. Don't forget to multiply by the distance, because work is force times distance. This first factor is the force in the direction of the distance, and so I also have to multiply by the distance, which was 40 feet. And so this is going to be 130 square root 2. No. One more zero there, right? Isn't it 1300 square root 2? Yeah. Okay. So anyways, that's how you do that. Work is force times distance, but of course only consider the component of the force that is in the same direction as the distance. Good morning, George.
The unit would be pound, right?
Yeah, so the force was in units of pounds force, and the distance was in feet, and so it would be like foot-pounds. would be the unit of energy or the unit of work. And this is not a physics class, so I don't really care about unit conversion. I'm not going to ask you to report this in joules or whatever.